let's look at some word problems for systems of equations. So this first one, we have the Lazy Daisy Landscape and Company, and they place 2 orders with the nursery. So the first order, it was 8 rose bushes, 4 fruit trees, which totaled $232. The second order was 6 rose bushes, 2 fruit trees, for a total of $140. And the bills did not list the per item price, so what we want to know is what did each rose bush and fruit tree cost. So how I highlighted this and how it kind of comes through with systems of equations is I think there's always these 2 scenarios that come through, and that's going to make your 2 equations that you're working with. So the idea being our first situation is this first order that was placed, and then our second case is the second order that was placed. So that's going to make our 2 equations. In terms of choosing what your variables are, they're often going to ask you exactly what they're looking for. So with this, that last question of what did each rose bush and fruit tree cost, so I want to find a price for rose bushes, and I want to find a price for fruit trees. So let me make 2 variables here. I'll just call R for the price of a rose bush, and fruit tree, let's go ahead with T for cost of a fruit tree. So that question at the end will often give you an idea of what you want your variables to be. So our first order, and that's going to make our first equation. So let's think about our first order and putting those pieces together. So we have 8 rose bushes, 4 fruit trees for a total cost of $230. So imagine a rose bush cost $2. So the idea would be that we would take those 8 rose bushes times the $2 for a total of $16, right? There's going to be this multiplication relationship between how many and the cost. Same thing with fruit trees. If the fruit trees were $5 and I got 4 of them, then I spent $20 there. So I'd have multiplication of those 2 numbers to get this total cost. So what I want to do is take 8 times the cost of each rose bush plus 4 times the cost of each fruit tree. And for our first order, that came out to $232. For the second order, we have a similar scenario, but just different numbers. We had 6 rose bushes and 2 fruit trees, and that came out to $140. So with that, we now have a system of equations, and it's all lined up, so that makes it easier. And now all we have to do is choose a method for solving. So we want to choose between the elimination or substitution method. And my instinct, and again, either way, and you'll get to the same answer, my instinct is that since I don't see any coefficients of 1, I'm not very inclined to use the substitution method. What I can see is this 2 and 4 work pretty nicely together. So if I could just get that positive 2 to bump up to a -4, it'd be pretty easy to use the elimination method. So that's what I'm going to do. I'm going to multiply that bottom equation by -2 so that I can get a -4 in front of t there. So my first equation, 8r plus 4t plus 200 equals 232. That equal sign there. And then for the lower equation, -2 times 6, so -12r, -2 times +2, -4t, equals -2 times 140, which is -280. And then we're going to add those 2 equations together. So 8 minus 12 is -4r. Positive 4t and -4t will cancel out just to 0, which is perfect. And then 232 minus 280 will be a -48. And I'm just going to divide by -4 So I can solve for R. So I now found the cost of a rose bush is $12. And then with that, I'm going to back substitute so I can solve for T. And you can choose either equation. Let's go with the first order. So 8 times 12 plus 4T equals 232. So that'll be a 96 plus 4T equals 232. I'm going to subtract 96 from both sides, which will leave me with 136. Divide by 4. We're going to get T equals 34. So we have our two costs. We could double check our answers before we go further, like plug these values in. Do they work for the equations? And we'll just say each rose bush costs $12 and each fruit tree costs $34. Alright, so there's a word problem. So think about trying to find those kind of two scenarios, and that will set up your two equations, and it's just a matter of getting the relationship. But what can be a really helpful place to start is just starting with the definition of what your variables represent, and that's going to come from this final question that they ask. So let's look at another scenario. So we have a school fundraising event, sold a total of 200 tickets, and raised a total revenue of $550. There are two types of tickets. There's adult tickets that sell for $3 each, and child tickets which sell for $2. Find how many of each ticket type, each type of ticket were sold. There we go. All right. So with that last question there, we want to find how many of each, I have to say it again, type of ticket were sold. So I want to know how many adult tickets, how many child tickets. So let's have A represent the number of adult tickets. And C can represent the number of child tickets. All right. So my two scenarios here, kind of like I was describing up above, is we have this idea of the number of tickets sold and this idea of the revenue of the tickets that were sold. So we're going to have kind of two pieces. The first equation is going to relate just to the number of tickets, and the second equation will relate to money. So if I have a total of 200 tickets sold, well, that would just be a combination of how many adult tickets and how many child tickets. So this number of tickets sold, we would just take A plus C, and when we add those two together, it should come out to that total of 200. For revenue, the idea is that we have multiplication, kind of like we did up above here with the number of rose bushes times the cost, or number of fruit trees times the cost. Same thing here, we would do like adult tickets, $3 for each adult ticket, and if we multiply those together, we get this total revenue from adults. And same thing if we do it for children, we have the total revenue from children, but then the overall revenue should be $550. So what we're going to do is take that $3 for adult tickets and multiply, so 3 times A, and then $2 for children tickets, 2 times C, equals $550. Okay, with this one, I'm going to go ahead with substitution method because I can solve for a variable pretty easily there. So I'm going to solve for A. So if I take that A plus C equals 200, I can solve if I subtract C from both sides. I have A is the same thing as 200 minus C. So what I'm going to do is take what I just found there, that A is the same thing as 200 minus C. So I'm going to substitute it into the other equation. So I'm going to go 3 times 200 minus C plus 2C equals 550. And then I'll distribute, so 600 minus 3C plus 2C equals 550. Combine like terms, so negative 3c plus 2c would leave me with the negative 1c. Subtract 600 from both sides, which would leave us with a negative 50. Divide both sides by a negative 1, or you could think of it as multiplying, but we're going to get c equals positive 50. And then I just need to solve for a. So if I take a plus c equals 200, a plus c, but c we're going to substitute in 50, equals 200. Subtract 50 from both sides. So we have 150 adults, 50 children. So 150 adult tickets and 50 child tickets were sold. All right, so those are word problems with systems of equations.